Hi, welcome back to my video. In the previous video, we saw how to terminate the direct connect connection, and in this video, we'll be going through the various preparations and especially to confirm the routing is in place in your data center devices. We'll be primarily concentrating on the core router, the edge router, and the ASA router. Their functions can be better seen as per the diagram that I'm seeing that you can see here. Now, let's start. These are the topics that I'll be covering through in this diagram, in this video. Now, in the core router, we'll be going through how the BGP is established, how the BGP neighbors are reached, and through that we'll be studying how the GRE configuration is done, and also how the GRE tunnel is being formed, the underlying routing for the GRE. We're going to verify all those things. And also we'll be taking a detailed look at the redistributions involved, that is the BGP to EHRP and the EHRP to BGP redistributions. From there we'll go on to the ASA firewall. From the core, as of now, the traffic goes to the ASA firewall, and the ASA firewall we'll be looking at the GRE routing and the GRE configurations, and of course the crypto configuration by which the traffic is actually getting tunneled to AWS infrastructure. Coming back to the edge router, we'll start off with the interface configuration so that we can terminate the circuit. Then we'll be going to the BGP configurations, and finally we are going to ensure that EHRP to BGP and the BGP to EHRP distributions are all in place. So this is a summary of what we'll be going through. So next, let's start with the core configurations. In the core, let's start with the BGP configurations. So first of all, we'll be checking out the show IP BGP summary to find out that these are the two neighbors that we have. Let's concentrate on dot 129, which is to CSR1. The other BGP is to CSR2. Let's concentrate on just one. Now the key point here is, so now let's look at how the neighborship is formed. As you can see here, this is the running configuration of that particular neighbor. You can see the passwords, you can see how the replays, how the AS number is set up. You can see the route maps in, you can see the route maps out. All pretty vanilla. It's a BGP configuration as you and I, we all know about it. Now, the next thing we're going to do is to look at how the BGP neighbor is going to be reached. We're going to look at the show IP route for the BGP neighbor. As you can see here, the neighbor is reached through tunnel 48, which is the GRE tunnel that we are using for this purpose. Let's now look at the GRE tunnel configuration. You can see the GRE interface IP. You can also see the tunnel source IP, the tunnel destination IP. These are the key parameters here. These are the key parameters that we're going to route. Let's start off with the tunnel source IP. When you do a show IP route, you can see here it is identified as a locally originated connected IP, that is a loopback 48. That's it. It does not have much more significance as that. Apart from that, we have that primarily so that we can redistribute it into EHRP and BGP. Let's now look at the destination route, the destination IP of the tunnel. As you can see here, the destination can be reached through a static IP. This is our current condition. It is a static IP going towards 10.15.240.5, which is of course our ASA IP address. Okay, so we now know that the GRE traffic, once it's getting formed from the tunnel source to tunnel destination, it is going towards the ASA firewall. Now let's look what's happening in the ASA firewall. In this ASA firewall, we can see that this IP is getting routed towards, here we have a placeholder public IP 5.5.5.5, which is the internet IP address of the internet interface. You may be using internet interface or an outside interface, whatever it is. It is a source IP for the tunnel, for the IPsec tunnel. As you can see, the GRE tunnel is getting routed over there, and once it's getting routed over here, we have the crypto map getting into place. Now you can see that this is the basic crypto map VPN configuration. You can see the match statement identifying the traffic that has to get tunneled, and of course you have the source IP, the peer IP configurations, and all those things. Now let's look at the GRE IPs are getting tunneled to this crypto map. Let's see the components of this crypto map. You have an access list, which is being called for this match IP address statement, and This acceleration in turn calls an address subject group in which our 10.255.249.0/25 subnet is being called, which as we know is the GRE IP addresses of the CSR routers. Now, as an extra bonus, let's see how the peer IPs are configured. You have the names and of course the peer configurations. Pretty well now. Now let's go back to the core and let's see how the redistribution happens. We are redistributing both EHRP to BGP and BGP to EHRP. We use a lot of route maps, but again, these are all permit route maps. We don't have too much restrictions on it because it's all internal, right? It's all good. And so we can see the redistribution happening. You can see the static is getting redistributed, connectors are getting redistributed all through various route maps, and most importantly, you can see the BGP to EHRP redistribution and the EHRP to BGP redistribution. So that is all the preparation that we need to do in the core router. Now let's look at the preparation we had to do in the edge router. Thank you. Now let's look at the edge router configuration. The first thing, of course, we need to do is the interface configuration. Now, we saw the template of what to do when we downloaded the script from our Direct Connect portal. And I told you that we don't need to worry about the VLAN that's mentioned over there. We have to use whatever VLAN ID is told to us by our connection provider. Now, here it is, of course, 4001. So, we are using 4001 VLAN to terminate our interface. Like as you can see, you have the interface configuration. Now let's jump into the BGP component. Of course, the first component is of course the prefix list and the route maps that use those prefix lists. So let's start with an inbound prefix list in which we are defining the 249.0/25. This prefix list we are going to use in a route map, which will be using the routing configuration. Then we are doing an outbound configuration, outbound prefix list, in which we are using a particular loopback interface that we have on the router. This is only to test. We are not advertising the GRE IP addresses from the core as of now. We need to ensure that the cutover has to happen only after all the other components are ready. So for test, we are adding this particular IP into the prefix list, which is being referenced into this outbound roadmap. Alright. Now we are finally coming into the BGP configuration itself. We are using whatever router BGP ID, the AS number is there in the router. And then as you can see here, we are doing the local AS prepend so that we can use whatever AS number that we received in the BGP configuration. As you can look in the image we discussed previously, we get that text file from the AWS portal for whatever configuration we had to do. Make sure it matches except for the VLAN part. Alright. Now the BGP configuration is done. Confirm the BGP is up. If you have done everything correctly on your Direct Connect end, at the AWS end, now the BGP will be up and you should be getting the routes. Now let's look at the other critical component, the redistribution part. As we saw in the core router configuration, core router preparation work, the routes are getting redistributed into EHRP. Let's first confirm whether the core GRE IP is learned by the edge routers EHRP. First step. After that, let's confirm that this IP is learned in the core routers, in the edge routers BGP routing table. If everything, all the redistribution is done, this will be successful. Next, we are going to confirm that the AWS CSR IP is being received by our BGP, most critical component. That's why we are doing all this BGP, right? Once it's there, let's confirm that it's being redistributed into EHRP by checking into the core. EHRP should have this route. The core router should have it in the EHRP routing table, but it will not be taken because why? We have a static route pointing towards the ASA. So now that you know that all your background preparation stuff is in place, let's now go towards the cutover. In the next video, I'll tell you how the cutover script has been prepared and how to implement it. Thank you.